Nissan e-Power fuel economy, the 2026 Honda CR-V Hybrid real-world MPG, Nissan X-Trail versus Honda Accord highway range, and the massive hybrid efficiency scam are the only topics that matters to anyone staring at the rising price of unleaded in 2026. But there is a brutal, research-backed truth about these two EV-feeling systems that the marketing brochures and dealership salesmen are desperate to hide from you until you're already 500 miles into your first family road trip. Why is it that Nissan is spending billions to convince you that e-Power is an EV experience without the plug, while Honda claims their HEV is the ultimate balance of power and thrift? Yet one of these systems falls off a literal efficiency cliff the moment the speedometer crosses 65 miles per hour. If you've been looking at a new 2026 Qashqai or a redesigned Civic Hybrid and wondering if the instant electric torque is actually a calculated trap for your bank account, your GearHead instinct is absolutely right to be suspicious, because the physics of energy conversion do not care about catchy slogans. By the time you finish this deep dive analysis, you will understand the precise engineering reasons why a series hybrid like Nissan's can actually be less efficient than a standard gas car on the highway. You will uncover the hidden conversion tax that makes the Honda system a superior long-distance tool. And you need to stay tuned until the very end, because I'm going to reveal a specific efficiency threshold number, a calculation buried in SAE technical papers that determines exactly when your Nissan e-Power becomes a financial liability compared to a traditional Toyota or Honda. This is the honest truth about Nissan versus Honda hybrid efficiency, and I'm answering the questions that are currently causing heated arguments in every engineering lab from Tokyo to Detroit. To understand why the Nissan e-Power versus Honda HEV debate is the most controversial topic in the 2026 auto market, we first have to address the EV without the plug lie. For decades, the automotive industry has tried to find a way to give drivers the silence and torque of an electric motor without the range anxiety of a battery. Nissan's solution is a series hybrid. In a 2026 Nissan X-Trail or Qashqai e-Power, the gasoline engine is a literal slave to the electric motor. It has zero mechanical connection to the wheels. It exists solely to spin a generator that creates electricity to power a traction motor. From a veteran gearhead perspective, this is a masterpiece of urban engineering because it allows the engine to run at its most efficient RPM while the motor handles the stop-and-go stress. However, when you take that same Nissan onto a sun-baked highway in Texas or Australia and try to maintain 80 miles per hour, the physics change completely. Because there is no mechanical link, you're losing energy at every step of the conversion: chemical energy to heat, heat to mechanical, mechanical to electrical, and electrical back to mechanical. Research into energy conversion loss shows that for every gallon of gas you burn in a series hybrid at high speeds, you are effectively throwing away 15 to 20% of your potential energy just in the handshake between the generator and the motor. Honda's HEV system, featured in the 2026 CR-V, Accord, and Civic, takes a radically more sophisticated series parallel approach that most buyers don't fully understand until they see their first highway gas receipt. Like the Nissan, the Honda spends most of its city life as an electric vehicle, using the engine as a generator. But here is the brutal truth that puts Honda in a different league for highway driving. The HEV system includes a high-voltage mechanical lockup clutch. When the car's computer detects that you are cruising at a steady highway speed, typically between 45 and 75 miles per hour, it closes that clutch and connects the gasoline engine directly to the front wheels through a single tall gear ratio. In this engine drive mode, the Honda is no longer a hybrid. It is a direct drive mechanical cruiser. By bypassing the generator, the inverter, and the electric motor, Honda eliminates the conversion losses that plague the Nissan. The result is a highway MPG that consistently beats the e-Power by 5 to 8 miles per gallon in real-world high-speed testing. If you are a father who does a 50-mile highway commute every day, that direct drive clutch is the difference between a car that saves you money and a car that just makes you feel like you're saving money. The controversy deepens when we look at the mechanical, stressed asset reality of the Nissan e-Power's engine choice. To act as the generator, Nissan uses their 5-liter VC turbo engine, a variable compression ratio marvel that is arguably the most complex internal combustion engine ever mass-produced. While this allows the engine to be incredibly efficient at charging the battery, it introduces a level of thermal and mechanical stress that is unprecedented in the hybrid world. At high speeds, because the engine has to generate enough electricity to move a 2-ton SUV and keep the battery buffered, it often runs at a constant high RPM drone. Research into long-term VC turbo reliability is already showing that this constant load cycle is brutal on the multi-link crankshaft bearings. Honda's 2-liter Atkinson cycle engine, by comparison, is an understressed unit. When it's on the highway, it's just cruising at a low, relaxed RPM in that direct drive mode. Dads across the globe are starting to realize that the simplicity of Nissan's drive feel is built on top of a mountain of engine complexity that might not survive the 10-year mark, while Honda has stuck to the mechanical fundamentals that made the brand legendary.
Let's address the psychological factor of digital seduction in the 2026 market. When you test drive a Nissan e-Power, you're seduced by the silence. It feels like a $60,000 luxury EV for $40,000. Nissan is banking on the fact that your test drive won't include a 2-hour highway stint at 75 miles per hour with a car full of kids and luggage. That is the efficiency trap. In city traffic, the Nissan is a king, often seeing over 50 miles per gallon. But the moment you add aerodynamic drag and sustained electrical demand, the system struggles. The engine has to work double time to overcome the drag, and because it still has to go through those electrical conversion steps, the fuel economy tanks. I've seen real-world highway tests where a 2026 X-Trail e-Power struggles to stay above 32 miles per gallon, whereas a standard non-hybrid Toyota RAV4 can hit 34. You're paying a premium for a hybrid system that on the highway is actually less efficient than a basic gas car. That is the definition of fake EV technology, and it's a hard pill to swallow for anyone who bought the car for its green credentials. The maintenance mystery of these two systems also carries a significant long-term cost implication. Honda's HEV lockup clutch is a wearable item, although it is designed to last the life of the car. However, in the 2026 auto market, we're seeing that the thermal management of the Honda system is much more mechanical and easier for an independent shop to understand. Nissan's e-Power, because it relies so heavily on the inverter to manage the total power flow at all times, creates a heat sink problem. The high-voltage inverter in a Nissan e-Power is under constant high-amperage stress every single second you are driving, whether you're in the city or on the highway. In a Honda, that inverter gets a rest during highway cruising because the engine is doing the work mechanically. High-voltage engineers will tell you that electronic components fail based on thermal cycles and total current flow. By giving their electronics a break on the highway, Honda is effectively extending the lifespan of the most expensive parts of the car. Nissan is running their electronics at 100% duty cycle, which is a high-stakes gamble on the longevity of the silicon and solder joints. The global perspective on this debate is equally revealing. In Europe, where highway speeds are high and fuel is expensive, the Honda HEV system is winning the efficiency war in independent head-to-head tests. In Japan and parts of Asia, where urban gridlock is the norm, the Nissan e-Power is a massive success because the highway MPG doesn't matter as much. But for the North American or Australian driver, where a quick trip to the store can involve 20 miles of highway, the Nissan system is a fundamental mismatch for the geography. We're seeing a reputation split in 2026, where the e-Power is being labeled a city specialist, while the Honda HEV is being praised as the universal hybrid. Understanding your own driving pattern is the only way to avoid the buyer's remorse that hits when you realize your high-tech hybrid is costing you more at the pump than your old V6. I want to hear from you in the comments below, because this is where the real-world data lives. Have you taken a Nissan e-Power or a Honda HEV on a long-distance highway trip, and what were your actual MPG numbers? Did the droning of the Nissan generator drive you crazy, or do you prefer the simulated gear changes of the Honda? Let's get a real argument going, because the truth about these fuel-saving technologies isn't found in a glossy commercial. It's found in the real-world experiences of the people who actually have to pay the bills. We need to hold these manufacturers accountable for the highway honesty of their systems, and that starts with sharing the data that the dealerships want to keep quiet. Now, as I promised at the beginning, I'm going to reveal the one specific efficiency threshold number that determines the fate of your hybrid's budget. That number is 12 kilowatts. In a 2026 series hybrid like the Nissan e-Power, 12 kilowatts is approximately the amount of electrical power required just to overcome the aerodynamic drag of an SUV at 62 miles per hour, 100 kilometers per hour. Below this threshold, the generator can loaf along and charge the battery efficiently. But the moment you cross that 12 kilowatt demand, which happens the second you hit highway speeds, the system enters maximum conversion loss mode. In a Honda HEV, that 12 kilowatts is delivered through a direct mechanical gear with nearly 98% efficiency. In a Nissan, that same 12 kilowatts has to be generated, inverted, and converted, losing nearly 3 kilowatts to heat in the process. This is the energy leak that car companies don't want you to calculate. You aren't just paying for the gas to move the car, you're paying for the gas to create the heat that is currently cooking your Nissan's inverter. If you're serious about getting the best MPG for your lifestyle and you want to arm yourself against the dealership's high-tech marketing and EV feeling deceptions, knowledge is the only tool that works. Dealerships are banking on your ignorance of conversion losses and mechanical lockup to sell you the car that earns them the most commission. Don't let them win. Arm yourself with the facts, see through the marketing fluff, and remember, in the 2026 market, the most reliable and efficient car is the one owned by someone who knows that on the highway there is no substitute for a physical connection between the engine and the road. If you appreciate this kind of veteran, fact-driven analysis that refuses to bow to corporate pressure, hit that subscribe button, turn on your notifications so you never miss a deep dive, and check out the video on your screen right now, where we break down why Toyota's move to zero W8 oil might be the biggest reliability mistake in their long history. This is GearHead Genius, and remember, every car has a story, but only the owners know the truth. See you in the next one.